Welcome to episode 60 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes the object so interesting to astronomers. So, I will now run the random number generator. And the random number generator seems mildly excited about the coordinates for this episode. The coordinates are 11 hours, 23 minutes, 20.7 seconds right ascension, and plus 1 degree, 37 minutes, 48 seconds declination. These coordinates point to an object in the constellation Leo called UM425. The history of UM425 is rather interesting. The object was originally discovered in 1981 in a survey led by Gordon M. McAlpine at the University of Michigan, which I am fairly certain is why the name of this astronomical object begins with UM. McAlpine had been searching for quasars in the visible part of the electromagnetic spectrum. A quasar is one of many different types of galaxies containing an active galactic nucleus, which itself consists of a supermassive black hole millions or billions of times more massive than the Sun, a disk of really hot gas falling into that black hole, and jets of gas above the poles of the black hole that originate from gas that got too hot as it was falling into the black hole and that ended up getting blown away instead. Many different galaxies have supermassive black holes, but in quasars, the jets of gas end up aimed roughly towards Earth, so the quasars tend to look very bright and point-like. Quasars are also generally found at distances of billions of light years from our galaxy. UM425 itself is at a distance of about 9.3 billion light years from Earth. While it is interesting that UM425 was identified as a quasar by Gordon McAlpine and his crew of trusty astronomy assistants and part-time Michigan Wolverines sports fans, some later observations of UM425 by G. Malan and S. Georgowski in 1987 revealed that this was more than just a single ordinary quasar. Their more detailed images revealed the presence of a second bright spot just above the center of the quasar. This second bright spot looked like a second quasar at the same distance as the brightest quasar, and with the same spectrum. It seemed a little too unusual to have two very similar quasars right next to each other in the sky at the same distance from Earth, and this led Malan and Georgowski to propose that they were not looking at two separate quasars, but two gravitationally lensed images of one quasar. Gravitational lenses are really exciting in astronomy. They are basically situations where, on Earth, we see a very distant object outside our galaxy, such as another very distant galaxy, behind another object that is still outside our galaxy but not quite as far away, such as another galaxy or maybe a cluster of galaxies. The gravitational forces from the closer object can actually bend the light from the more distant galaxy, and this can produce all sorts of really cool effects, including distorting the light from the more distant object into weird circular arc-like shapes, magnifying the light from the more distant object, and producing multiple images. And this last point is why people identified UM425 as a potential gravitational lens. Gravitational lenses can be used for all sorts of different things in astronomy. First of all, astronomers can model how the closer objects distort the light from the more distant objects to determine how mass is distributed within the closer objects. This in turn allows astronomers to search for dark matter, which is stuff that neither absorbs nor emits light or any other form of electromagnetic radiation, but which exerts gravitational forces that help to hold galaxies together. Astronomers can also look at the distorted light from the more distant galaxies, which otherwise would be too faint to see if they were not lensed, to understand them better, and astronomers can even use models to reconstruct what these distorted-looking galaxies actually look like. Additionally, statistical information on the number of gravitational lenses in the sky could also be used to test models of how the universe formed and how fast it has been expanding over time. When UM425 was identified as a potential gravitational lens in 1987, it was particularly exciting because up to that point, astronomers had been having severe difficulty finding gravitational lenses even though they were expected to exist theoretically. Follow-up observations of UM425 in the 1990s and early 2000s sought to confirm that this object is indeed a gravitational lens and not just a pair of quasars sitting next to each other. And astronomers concluded that they could not reach any conclusions regarding the actual nature of UM425. Astronomers did find a cluster of galaxies in between us and UM425 located at a distance of about 6.8 billion light-years. This cluster of galaxies as a whole appears to have the mass to gravitationally lens the light from the more distant quasar. However, astronomers did not find any of the distorted arc-like things that people have seen when looking at other gravitational lenses, and they could not exactly figure out how the closer cluster could lens the more distant quasar unless the cluster had a really massive but very faint galaxy with enough gravity to do the lensing. This would imply that UM425 could actually be a pair of quasars. However, if UM425 was actually a pair of quasars and not just two gravitationally lensed images of one quasar, it would be peculiar that the two quasars are not only located at exactly the same distance, but also have very similar spectra. In fact, the probability of selecting two quasars from anywhere in the sky with the same type of spectra as seen in the two quasars in UM425 is 1 in 20, at best. Unfortunately, since astronomers couldn't figure out what was happening with UM425, they moved on to working with other things where they could definitely tell that the objects were either pairs of quasars or gravitationally lensed individual quasars. Maybe someday, though, astronomers will take another look at UM425 and will be able to figure out exactly what's happening. And that's my summary of UM425, and the location on the Earth's surface corresponding to the position of UM425 in the sky is located about 230 kilometers west of Tarawa Atoll in the Gilbert Islands. These islands are part of the Pacific island nation of Kiribati, and Tarawa is the capital of the country. However, Tarawa is most notable as the site of a very brutal World War II battle in November 1943, where 18,000 United States Marines launched an amphibious assault to capture the atoll from 4,500 very well-entrenched Japanese soldiers. The battle lasted 76 hours, and over 6,000 soldiers died. Now, though, Tarawa is a much quieter place that isn't involved in any military conflicts whatsoever. Like the rest of the nation of Kiribati, it doesn't get many tourists, so if you want to go someplace quiet in the tropics, then you should consider visiting Tarawa. The website for this podcast is www.randomastronomicalobject.com. You can visit the website to download episodes of the show, read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. You can also find this podcast on Facebook and on Twitter. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, and the sound effects are from the Freesound Project at www.freesound.org. Thanks for listening.